Phones and computers have basically become the things our lives revolve around. 99% of jobs and most schools require some sort of computer in order to fulfill the task at hand. And all of you watching need some sort of computer to see me in the first place. However, as Aristotle once said, the simplest things are the ones we take for granted. Touchscreens are not simple though, but it would still be cool to know how they work. I'm not sure if that was Aristotle or not. Roll title. So anyways, how's your day going? Comment it down below. And while you're doing that, notice how quickly your phone responds to each tap you make. It's unlikely that you've ever stopped to wonder how tapping some glass can help you take part in a conversation with random strangers you can't even see or hear, who are probably from other parts of the city, country, continent, or world. A single sheet of glass, separating you from endless possibilities. Trademarked. Touchscreens generally come in two forms, both used for different purposes. The first kind is a resistive touchscreen. These are displays usually made of some sort of tough glass or plastic, and are found in places like ATMs because of their high durability. Resistive screens are purely based on the pressure of your input, meaning that any material with a strong enough force will be able to activate it. You can touch it with a glove, your clothing, or even something more solid like plastic. They're built so that the material you're pressing on comes in contact with another plate underneath, which creates a conductive signal, referencing your input. Capacitive touchscreens are the second type and work a bit differently because they actually rely on tiny electric reactions in your fingers to conduct a signal. Your fingers have a certain amount of electricity running through them at all times, which is why you can feel static. There are multiple kinds of capacitive touchscreens which are designed differently depending on the size of the device. Surface and projective. Surface screens use sensors and an extremely thin film that moves and sets off the sensors in the screen. Projective screens use a projected grid made from tiny chips that act similarly to resistive screens, except they too require those electric finger reactions you make. These capacitive layers generally have a clearer appearance and allow for sharper images and are used for computer touchscreens, smartphones, and tablets, and even some TVs. Speaking of TVs, they have their own form of capacitive screen, frustrated total internal reflection. You don't need to remember that. These are thousands upon thousands of small cameras in the sides of the screen, which detect where and when light is scattered on the TV and sends signals to the respective locations. Pretty neat, right? If you've ever splashed water on your phone by accident, or on purpose, you may have noticed that it sometimes activates a button on the screen. This is because water contains little ions formed from dissolved materials that used to be in the water, which happen to have similar electrical currents as the one in our fingers. The only water that can't conduct electricity is pure water, or water containing absolutely nothing but H2O. Capacitive touchscreens are usually made from silver, copper, or indium tin oxide, which are all great conductors of electricity. You've probably heard and seen silver and copper wires, but I doubt the term indium tin oxide is very familiar to you. That's why I'm here to explain it. ITO is made of indium and tin, which work in cooperation with vanadium oxide to transmit electric currents most efficiently. As your finger transfers energy to the VO, that then gets deposited on the surface of the ITO, which sends a signal to the inside of the device that there was an input. Confused? Me too. Now, in order for us to visualize this, we have to consider three things. First of all, our touchscreen. We can't have our phone without our touchscreen. We also need our finger. Beautiful little finger there. And it is going to touch this touchscreen right here. Now, underneath this touchscreen is the motherboard. So we have the motherboard of the phone, or whatever the touchscreen is. Now, within this motherboard, we have something called the Image Processing Controller, IPC, Image Processing Controller. Now, this is where everything that you input with your finger is transmitted to, and it is therefore relocated onto the screen so that it knows where your input has been. So here's the motherboard, and here's the IPC. Now this is the touchscreen, and within the touchscreen we have a bunch of little materials, and those materials consist of glass. That's the main structure of this touchscreen. And then on top and on the bottom we have little ITO, indium tin oxide layers. ITO, ITO. And those are for receiving the electrical inputs from your fingers. Now on top of these, this is where your finger actually touches. These are the vanadium oxide bumps. And basically, when your finger releases these electrical signals, these pick up those electrical signals and they transfer them to the ITO through the glass to the other set of ITO, and then this then gets transferred to another area, which isn't actually a physical area, but rather just a thing that happens when you touch this touchscreen. And this is the electromagnetic field. Now, this electromagnetic field knows when you've touched the touchscreen because your finger, with that electricity coming out of it, makes disruptions in the electromagnetic field. So if nothing was touching it, it would just be straight like this. But since your finger is touching the touchscreen, it is causing a disruption, and then the ITO recognizes that, and then it transfers that information to the motherboard and therefore the IPC. So to recap, your finger touches the touchscreen, which consists of vanadium oxide, ITO, glass, and more ITO, which picks up those electrical signals and it sends the electromagnetic field's disruptions to the motherboard, and then the motherboard also the IPC, the image processing controller. ITO is clear in singular layers, but is slightly more durable and slightly less scratchable than normal glass. When stacked multiple times, ITO gives off a yellowish or grayish appearance. It has a low electrical resistivity, which means that it's fairly sensitive to most electrical signals. Finally, the reason why screen protectors work is because they are made of materials such as polyethylene terephthalate, a type of plastic, thermoplastic polyurethane, another type of plastic, or laminated tempered glass, all of which are able to carry out electrical signals that are received from the fingertip. So, that's the deep dive I was planning to get into. Awesome! If you have any questions, you can shout them out once the video ends, or comment them if you're here on YouTube. As always, significant sources and song credits are referenced in the description. That's all from me, and I wish you a wonderful breakfast.